So here's the homework question involving the double ball bounce. And you can see I put it here with the answers already in place for the numbers that are given. And I just want to talk about this elastic collision that happens here. So the elastic collision involves the basketball moving upward with 5.14 meters per second and the tennis ball moving downward with 5.14 meters per second. And that's just out of the regular 1/2 mv squared equals mgy analysis. So now what we need to do is we need to do the elastic collision. And like I showed in the lesson and in the examples that I did last week, the easiest way to deal with the elastic collision is not to use momentum conservation and energy conservation. The easiest way to do the elastic collision is using relative velocity method. So I start by calculating the total momentum, which is m1 v1 plus m2 v2. So I would use 567 times 5.14 plus 57 times negative 5.14. Notice that the tennis ball is moving downwards. So that gives me a total momentum value as a number. Then I want to use the idea that total momentum is equal to the total mass times V center of mass. In other words, V center of mass is equal to total momentum over total mass. So it's going to be the previous answer divided by 567 plus 57. And that's going to be a number, and it's going to be upward in this case because the basketball is heavier. So overall, the average of these two things is moving upwards because the basketball's mass is moving upwards. So there's kind of a reasoning about why this is true for this particular case. So there's going to be this value here that gets calculated that goes over to here. So now we know the center of mass velocity of both of these objects. Which object do I care about? I care about the tennis ball. So then I'm thinking about V2 before the collision, and I want to subtract the V center of mass. So this is going to be our minus 5.14 minus, and I'd like to get a number for that, so let me just type this in real quick. 567 times 5.4 minus 57 times 5.14 divided by 567 plus 57, parentheses in all the right places, and I get 4.20. So this is 4.20. So this combines to get minus 9.34 meters per second. And this quantity that I just calculated has a name. It's called V2 initial prime. And it is the velocity of the tennis ball with respect to the center of mass. There's this center of mass dot, which is like here, which is kind of partway in between the two objects, and it is moving up with 4.20. meters per second of velocity. So with this relative velocity idea, that's how fast the tennis ball is moving with respect to this blue dot. They're heading at each other, and the combined speed is 9.34 meters per second, and the tennis ball is moving downwards as compared to the blue dot. So now we can just calculate V2 final prime is minus elasticity V2 initial prime. This is an elastic collision, so it's just 9.34 without the minus sign. And now we can take V2 final prime and plus V center of mass is 9.34 plus 4.20 is 13.54 meters per second, and that is V2 final. So this is the result of the elastic collision. Now we've put this into 1/2 mv squared equals mgy, and we can find the final height to which that object reaches. But the center of this calculation, the difficult and most important part of the calculation, is calculating what happens in this elastic collision. And this method of finding the V center of mass, then using the V center of mass so that you have relative velocities works really well, because relative velocities do easy things. You just, for an elastic collision, just flip the sign, and then you can unsubtract the center of mass velocity and magically get your result.